Welcome back to our next video. In this video we're going to be covering tutorial number 4. There's a few new things that we're going to learn here, actually quite a few. First off, the thing that you might notice is that this has a thread on it. So we're going to learn how to do threading command, threading toolpath, that is. We're also going to learn how to do a grooving toolpath. We're going to groove this out. The other thing that we are going to do is we're going to learn how to get rid of this. So we're going to learn about the plunge command in either the finish or the rough. So we'll talk about both of those. So let's go ahead and get started. The one thing I'd like you to notice is that when you first look at these drawings, the best thing for you to do is kind of think about it. Take a second to think, how am I going to create this part? If I start from here, I can come around and go to here, to this point, and then where do I go from there? 2 inches? Yeah, so I can do that, and then I have to create this radius here. So I don't know where the start and end points of this radius are, but I do have a center for the radius. So I can create a circle and then do some trimming. So I'm going to actually start out with that circle. And this is the way I choose to approach it. You could do it differently. You could draw this whole profile and just put a straight line all the way across here and then just come down and trim that. I'm actually going to draw the circle first, and then I'm going to draw the profile. And I'm also going to draw this in the positive just because it's dimensioned that way. It makes it a little easier, and then I'll just translate it back like I did in the last lesson. Only I'll do that before I apply the toolpaths this time. Okay, so let's get started. Okay, so we're going to go to, circle. Now looking at this drawing, I note that it is 2 inches. Well, that is a 2-inch radius because it's from the center. So my center point actually has to be 4 inches. So it has to be a 4 for my X or my D coordinate. And by my D coordinate, I mean this one here. So I need to put 4 inches in and a positive 1 inch in the Z. So I'm going to enter 4.0. Oops. Let me put my radius in first. 1.5 inch radius. And my fast point. And I'm going to go 4.0, comma 1.0. Enter. Okay, that looks good. Now let's make sure I did it right. We're going to start from the back. And I'm going to go 1.44, comma 0. Enter. Okay, this looks good so far. And 1.44, comma 2, enter. Also still looking good. All right. Now, if you notice, the next thing we need to do, we are going to a diameter of 625. So we're going to come down into that groove, and that is going to be 0.625, comma 2.0, enter. 0.625, comma 2.25, enter. Now we have a thread that is 3/4 of an inch, so we're just going to go to that nominal diameter of 3/4. So I'm going to go 0.75, comma 2.25. I think I messed that up. I did 2.25. There we go. Enter. And then we're going to go to 0.75, comma 3.0, enter, and 0, comma 3.0, enter. And that is the end of our part. Okay, so since we have that accurately drawn now, what we're going to do next is we're just going to add the chamfers, and we're going to, of course, get rid of that. Okay, so now we're going to add the chamfers here. We need a chamfer here and a chamfer here, and they're both 0.625. And now this also says that I need a chamfer back here, but not to worry. Remember, we can do the chamfer on the cutoff, and that is where I'm going to do that chamfer. I know that the book has you do it a little bit differently, At least I believe it does. Last time I went through the tutorial, it did. I am actually going to do it with the cutoff blade rather than doing it with a finish tool or anything like that. So I'll demonstrate that when we get there. Okay, so let's start off by roughing this part out. Well, actually, let's start off by creating our stock. Actually, let's start off, let me do that again. Let's start off by going to transform, and let's move this to the origin first. Okay, so now we're at the origin. All right, so if I go to wireframe, you notice that changed colors. You should know this by now, but you can just reset those colors, just clear the colors, and it'll go back to normal. Okay, so the first thing I'm going to do, again, is go to my stock, and we're going to change this to DZ, check, and properties. Everything looks pretty good in here. Our length, though, is going to be 3.0, and our diameter is 1.5. I'm okay with using 1.5. We'll use that for this one. And let's hit check. And properties, we're just going to do from stock, and check. Okay, so there is our part. So now we're ready to do our face. So let's go and start by going to turning and facing this part. And right here's our tool. And I'm going to hit check. And it's going to face our part for us. The next thing I'm going to do is go and rough this. Hit check. Tool is good. Everything is set already, of course, and we are good. Now, notice that it did not cut into here, and it did not cut into here. We have an option that we can make it cut into there, and I'm going to demonstrate this on the roughing pass. We can do it on both finish and rough. It's called Plunge Parameters, and as you can see here, basically there's no plunging allowed, either in the Z or in the X. That's what I have it set to. This one will allow it to plunge in both Z and X. This one will allow it just to plunge in the X, and of course this will allow it just to plunge in the Z. I only need to plunge in the X here, and I'm just going to demonstrate this. You need to set these clearance angles. If you don't have a clearance angle, it's probably not going to work correctly. So I'm going to hit check. I'm just going to leave them as is and hit check, and let's regenerate to see what happens. Okay, so right here you can see we're having a collision with the tool, with the stock. Right there, it's plunging into the part. Now this took a little bit, but really what did that do for us? It didn't really take a lot of stock out, so there's no reason to plunge that. So we're going to leave this on, or off I mean, and I'm going to hit check, and we're going to regenerate that. Okay. All right, so the next thing I want to do is I want to find a way to basically get this material out of here. And probably the best way I can do that is I can use a different tool to rough that out. So what I'm going to do is I'm actually going to select my roughing pass. And I could do this with just a finish pass, and I believe that's the way your book has you do it. But I'm going to show you both. So I'm going to select that, and I'm going to select a different tool. I'm going to select my profiling tool. And I'm going to allow this to plunge in the X. And hit check. And I'm going to take 0.025 for the depth cut. Okay, so you can see there's an issue there, right? Let me click out of there. You can see what the issue is. It's actually gouging into the part here. Now, why is that? It looks darn good over here, right? Well, the reason why that is because of our lead-in. Remember, our lead-in is set to be straight at basically 180 degrees. So let's go in there and take a look at that lead-in. So if we look at that, you see our lead-in is going, if our tool is in the center here, it's going straight in. That's not going to work for us because we're going to be starting inside the part. So the best thing we could probably do is actually set it to either a -45 or even a 90 would be better. I'm going to set it to -45 and we'll see what happens here. The other thing I want to do for this is I'm actually going to extend the lead, the contour, so that this contour actually goes up a little bit. 0.145 and hit check. And the other thing I'm going to do is I'm going to change this to remaining stock because I've already cut a little bit off of here. So I'm going to hit check and I'm going to regenerate that. Now that looks significantly better. Let's give that a play and see how it goes. Yeah, that is very nice. So I like that. Now, the book has you do it a little differently, and that's okay. So what I'm going to do here is I'm going to go ahead and finish this quickly while I have my finishing tool activated. And of course I'm going to use this whole path and hit check. Actually, no, cancel that. I'm actually going to groove this out before I do either of these. So before I do this one, I'm going to groove it out. And I'm only doing this for tool order. If I go and do the finish pass and I have my plunge on for the finish pass, which I'm going to need to finish this, the problem with that is I'm going to plunge down into this. So I want to cut this out first. So I actually want to cut that out before I do this arc up here, because just for tool order, I don't want to switch to my finish tool and then switch back to my grooving tool and then switch back to my finish tool. Why not do my grooving tool right after the rough, and then I'll just use both my finish tools after that. So I'm going to move my arrow up to after the rough, and let's do this groove. So we're going to do this groove. Now there's a couple of ways we can do the groove. We can do 1 point, which basically tells it essentially where it's starting. We can do 2 points, which tell it the depth. But it doesn't, if you do just the depth, it's assuming that the part is straight all the way across. The problem is we have a wall here. So we need to take into account for that wall. So I am actually going to, we can also do 3 points, which is 3 lines. This one would be okay. So I can do that one, or I can do the chain. And I always like to do the chain. The chain is actually for kind of like a custom shape if it's more than just 3 lines. So 3 lines or the chain would be fine. I always do the chain just because I like to do the chain. So I'm going to hit there and hit check. Okay, and then I'm going to come in and I'm going to grab my 1/8 inch tool and I'm going to hit check. Okay, and let's look at our shape. So I'm going to use the stock for the outer boundary, obviously. My grooving parameters, we're going to take a look at these. So I'm going to do bidirectional. Basically what that means is it's going to kind of start in the middle and start grooving it out. So it's going to start plunge right here, move over this way, groove this one, move over this way, groove this one. And it's going to kind of work its way out from the middle. I'm okay with that. It doesn't really matter. I could do positive first, so it grooves everything out there. I could just do positive where it starts back there, or I could do negative where it starts up front and just works its way back. It doesn't really matter. It's not a big deal. So what I'm going to do here is I'm leaving 5 thousandths for this to finish. You can see here the stock clearance. This is how far it's going to start feeding from the stock diameter. And then we have the percentage of tool width. This is how far it's going to step over. So it's going to step over about 75%. And that goes back to the fact that I said you don't want most of your tools sticking off. You actually want to have a heavy step over here so that this tool doesn't deflect when it hits the material. So 75% will be good. The back off, this is just how far it's going to back off after it makes that pass. So say it's plunging right here on this blue line. Once it gets to the bottom, it's going to back out 20% and straight back out after that. Z leave is just how much it's going to leave on our Z, this green area that's leaving around here, and then of course our X is this green on the bottom. It's just how much extra stock we want to leave. We're only going to leave 5 on. I know that I said that you, in past lessons, that you want to leave about 10, but for this grooving operation, 5 will be plenty. Okay, so we're going to go about 2 thousandths for our first plunge. We can actually control our first plunge since we're taking the whole width of the cutter. We can control that separately from the overall feed rate, which is 2.5. Retraction moves, we're going to make them all rapid, so every time it pulls back out, it's going to be a rapid. That's okay. We don't really want to take any dwell. A lot of times, if you do that, you will get some chatter. For grooves that aren't square, that are kind of angled like this, you can either have groove walls or you can have smooth. It'll actually come in and it'll step. As it's coming out, it'll kind of angle itself so it creates a smooth wall. Steps are fine because we're going to do a finish pass here. Okay, so that's basically what everything does here. Now we can go to Groov Finish, and we are going to finish this. And we are going to take one finish pass. Our finish step over is irrelevant because it's just going to be whatever we left on. Stock to leave, we're not leaving anything. And basically this is just the direction of our pass. So the first pass is going to be clockwise. So in this case, the first pass is going to go this direction, and then it's going to go basically down a little bit past the middle, and then it's going to come in and do the other way a little bit past middle and come out. It's going to meet down here in the center again. We don't want any corner dwells. That's just so it can dwell in the corner. Compensation type, we're going to turn our wear on as always. And the middle overlap, we can have a little bit of overlap there. We'll make that 0.02 between passes. And then we don't have any undercuts or anything like that, so we're okay. For our lead in, it looks like we're leading in at 45 degrees, and our lead out is also another so our second pass lead in is coming from this direction, so that's second pass when it comes in here, and the first pass is when it comes in to this corner, and that's just fine. We'll be okay with that. We can also just change that to straight. I actually prefer it to be straight, so I'm going to hit check, check, and there is our pass. Now it looks like it's all over here, but keep in mind these lines are showing the left side of the cutter only. They're not showing the center, so that's why it looks like that. Okay, so now we've done our lathe rough, and we're going to do our lathe finish. So I'm just going to select here and hit check, finishing tool, and our plunge parameters need to change. Our plunge parameters need to allow us to plunge in the X, and I'm going to hit check. And we should be okay with all of our lead-ins because we're starting down here. We're not starting in any kind of groove. And I'm going to hit check. Okay. So let's take a look and see what we've got there. And I would say that that looks pretty good. Now, the key to being able to do this with this cutter, so while I have this up here, let me kind of show you. The key to this is that this arc isn't too great. There's enough clearance on the back side of this tool that allow us to get in here. If this arc was smaller, it was a really small arc, this here would gouge on the back side. So you have to make sure that this tool has clearance on this side here. An example of that would be if I were to use my roughing tool. It would not be able to cut this. It would actually create a straight line here, like you saw when I actually tried to do it. It can't get down into this, but this tool does have enough clearance where we can get in there, and the best way to tell that is just to look at it and make sure that you see that line visible. Okay, so that looks good. All right, we are now ready to do our threading. So let's go ahead and do a threading pass. So we're going to pick thread, and I'm going to pick a threading tool. I'm going to do an OD right-handed thread. Hit check. Okay. And remember, I didn't really set any of the defaults in this, so I'm going to have to go through this one. So the lead of my thread, it appears, is a 10. So that means that 1 divided by 10, of course, that is 0.1. So we have a lead of 10, because this is in threads per inch. Inches per thread would be 0.1. So threads per inch, and then our included angle, of course, is 60. Our thread angle, of course, is 30. Major diameter. All right, in this case, our major diameter is 0.75. Our minor diameter. Well, our minor diameter is going to be determined actually by the depth of our thread. So if you remember what our single depth, we can select this from compute from, let's see here, we're going to do it, select from table. So that's the problem with running this. We have to either know these numbers or we can select them from the table, which is an easier way of doing it. So we're going to go UNC, select our correct thread size and our type, and then 3/4 inch 10, and take a look at that. We have all of our information is put in there for us. Makes it nice and easy. Our start position, of course, will be 0, and our end position will be right there, negative 0.75. Okay. Thread orientation is OD, and it is not an angled thread. Allowances, we're not going to leave any allowances. And our thread cut parameters. Okay, so this allows us to adjust some things here. We're going to do one spring pass at the end. That means basically it's not going to cut any material. It's just going to go over and cut anything that it wasn't able to cut or sprung away. Clearance is how far it's going to start feeding from the edge of the part. And then this here, this anticipated pull off, we actually have that at 0, so that's good. We don't want that pulling away at any point. We want a full thread. Clearance is 1 or 0.1 above. That is good. And any overcut. Let's make a little bit of an overcut. Let's make 0.02 of an overcut. That just means it's going to make sure that it doesn't stop right at 3/4 inch. It's going to go a little bit past there just to make sure we get a full thread on there. And this here depends on whether we can do that without running into this wall. So you want to maximize it. I'm going to make it 0.0. Actually, I'm going to make it 0.1. And you'll see how this becomes an issue if we make it too big. And then we'll come back and change it. So I'm going to hit check. Okay. I don't think it made it too big, but let's give it a go and see how it looks. Okay, so 0.1 was an okay amount, and it did thread the whole way. Now, notice this does not simulate helix. It just simulates grooves around there. That's fine. I mean, it's very difficult for it to actually simulate a real helix. I think there is a way that you can get it to do it, but I generally don't worry about it because all I want to see is that it's actually cutting a thread. So it did not hit into there. I'm going to do it so it actually does hit there. So let me do 0.2 and regenerate that. Okay, so there you can see a crash right there, that dotted line. So let's run that and show what happens. So you got to be careful. That's basically my point here. Okay, so right there, it actually hits into the side of there. And you can tell that's not right. So we're going to go back and reduce that back to 0.1. So you just got to be careful with that just to make sure that you don't do too much of an overcut. Okay, so that is our part. Now all we got to do is cut this thing off. And if you remember, we had a chamfer on the cutoff. This is going to be our cutoff tool. And if you look at our cutoff, actually let me change this since we're pretty close. We're going to make this holder, make C 1.0, check. And from stock, everything here is good. The only thing we really need to change is this. We want to change our chamfer. If we look at that print, it's telling us that we have a 62 thousandths chamfer, basically a 16th of an inch chamfer on there. Alright, so we're going to go back and we're going to change that because I only have a 15 thousandths, 0.0625, and I'm going to hit check and check again. Okay, so there is our chamfer. It automatically put that on there for us without having to plunge our finish tool in there and do all kinds of weird stuff. This is a much nicer way of doing it, provided also that you have a very rigid cutoff tool. If it's not rigid, it's going to flex when it's trying to cut laterally, and you're not going to end up with a good chamfer. So it is important that you have a good setup to be able to do this. Otherwise, if you are stuck with a setup that's not as rigid, then you may have to use the finish tool like the book did. Okay, let's take a look at this in our simulation. And I would say that is a good looking part. So there we go. Got our chamfers and finished part. Well, in any case, that is all I have for you today. If you have any questions, let me know. I hope that answered any issues that you may have had with the exercise.